This question is about transformation. So question number A is about modulus transformation. Now a little bit of a reminder, in C3 the modulus transformation is where this is also called the absolute value. The modulus function, also known as the absolute value, is when you have an absolute value of something, for example 3, the value is going to be 3. If it's the absolute value of -3, the value is also going to be 3. So what it does, it strips the number of its sign. So it will, if it's positive or negative, you just remove that number and that becomes the value when you remove it. So in graph, what it means is that if anything that is negative means this region below the x-axis is negative, when you have that absolute value symbol, this thing is automatically made positive. So for example, if this is minus something and if you make it positive, it is going to be reflected upwards. That's what it means when you convert this into graphical mode. So when you think about a modulus function, absolute value of fx, it means any negative y, any negative value here, because y is fx, it will be reflected upwards. So it will become something like that, like this. On the other hand, if you have, so this one was absolute value of fx, which means reflection on the x-axis, because fx means the value of y equals to fx. But on the other hand, if you have anything on the x, so if you have a negative x, it means it becomes positive. So what happens, there's a reflection on the y-axis. So these are the two transformation when we have C3 modulus function. And in this the first sum here is actually not a modulus transformation, it's a regular transformation which says y equals to fx plus 1. So fx plus 1 means, so this first one, let me remove this. So fx plus 1 means fx plus a. It means the picture is going to move backwards. Remember, it means x minus a. So this is what it means. So let's do question number A. So this is the axis. You have to give x, y and the origin. So it is x minus 1, that x plus 1, so it is going to be x minus 1. It is going to move backwards. So if you have this x coordinate, this is 3, it will become 2. This is minus 1, this will become minus 2. This is 1, this will become 0. So the picture will be somewhat like this. So it will be someone like this, and this would be 0a, this would be minus 2, this would be 2. So this would be a picture. Now this point B here, it would be somewhere around here now. So it would be b minus 1 now. So we don't have to put that, because indicate clearly on each sketch the coordinates of any point of intersection with the axis. So axis means x-axis and y-axis, so we don't have to say anything about this one. So this was y equals to f x plus 1 transformation, this one. Now for B, we are doing the modulus transformation. So the modulus transformation here would be modulus of x. So the modulus of f x modulus of x, f modulus of x means if you have a picture, it will be reflected on the y-axis. But remember, anything that is negative is automatically eliminated, and the negative looks the same as the positive. So this would be, so the first idea is draw the sketch without the one that is on the negative x-axis. So the picture looks like this. So it will look like this. So we have removed this one. Now this is 3 and this is B, this point is B, and this point is 1A. Now what you have to do, reflect the same picture on the other side, on the negative x-axis. So it would be like this. and it would be like this. So this is what it is. So this would be minus 1 a. So this is what the picture looks like, and if you reflect this to the other side, this would be minus 3. So when you have f absolute value of x, y equals to f absolute value of x, what happens? You take the picture on the positive x-axis, you remove the picture on the negative x-axis, and then you reflect the positive x-axis onto the negative x-axis, because absolute value of x means the positive x and the negative x, they're going to be the same. That's what's going to happen. So this is the picture. So you remove this portion and you reflect this to the other side. So this was 6a and b. The next question here is, they have given an equation of the sketch that we have, and all we have to do is find the value of a and b. So if you take a look at the original sketch, a means when x equals to 1, y equals to a, and b means where does the picture cut the y-axis. So they have given this fx, this exact sketch, they have given the equation there. So a means when x equals to 1, y equals to a, and b means y-axis, that means when x equals to 0, y equals to b. So using that information, we can find the value of a and b. So when x equals to 1, if we put it here, it would be y equals to 1 minus 1 minus 2. So I'm putting 1 here. So 1 minus 1 is 0. Minus 2. Absolute value of 0 is 0, because 0 has no sign, plus or minus, it is 0. So 0 minus 2 is minus 2. So the value of a is minus 2. Therefore a equals to minus 2. Next, when x equals to 0, remember y-axis, x equals to 0. So here what's going to happen? Y equals to 0 minus 1 minus 2. So instead of x, I'm putting 0 here. So 0 minus 1 minus 2. So absolute value of minus 1 is going to be 1. Remember, when you remove the absolute value sign, the modulus sign, you just remove the negative or any sign, so it becomes 1, and there is minus 2. So 1 minus 2 is minus 1. So therefore b equals to minus 1. Always restate your answer. A equals to minus 2, b equals to minus 1. Of course, both a and b are bound to be negative. If you look at the original sketch, you will see that both of them are below the x-axis, meaning negative y. Question number D is solving the equation. So you have fx equals to 5x. So fx is absolute value of x minus 1 minus 2 equals to 5x. Now when you have to solve a modulus function, the most important thing is to put everything that is outside the modulus on one side. So x minus 1 absolute value equals to 5x plus 2. Now to solve this thing, the rule is, when you have, suppose absolute value of x equals to a, so you solve this equation by saying x is equals to minus a, and then you say x is equals to plus a. So when you remove it, this value can be plus or this value can be negative. So here what we have to do is write it twice. So we rewrite for x minus 1 equals to minus 5x plus 2, which means x minus 1 is minus 5x minus 2, which means if you bring the minus 5x here, it becomes 6x. If you bring the minus 1 there, it will be 1 minus 2, which is minus 1. Therefore x equals to minus 1 by 6. Then you write for x minus 1. Now this time it will be positive, because we took negative ones, then we have to take positive. So it will be plus 5x plus 2. So it would be x minus 1 equals to 5x plus 2. So it would be x minus 5x is minus 4x equals to 2 plus 1 is 3. So this would be x equals to 3 by minus 4. Now we found two values of x. One is minus 1 by 6, the other one is 3 by minus 4, or minus 3 by 4. But the question is, they told us to find the value of x. Now this is often the case. They tell us to find the value. So in order to know which one of the two would be our value, we have to check. This can be done by checking in the original equation whether this thing holds true. So let's first put x equals to minus 1 by 6 in this equation. X minus 1 equals to 5x plus 2. So if we do that, let's bring out the calculator. So if we do that, what happens is that x minus 1 means minus 1 by 6 minus 1. So that is minus 7 by 6. If you remove the absolute value, it would not be negative anymore, it would be 7 by 6. So on the left hand side we have 7 by 6. So now let's check the right hand side. So 5 into minus 1 by 6 is minus 5 by 6. So minus 5 by 6. And then on the other side we have plus 2. So plus 2. So this is 7 by 6. So this side, left hand side is 7 by 6 and the right hand side is 7 by 6. So x equals to minus 1 by 6 would be true. Now if you check the next one, it would never work because only one of them will work. So let's check if this one holds true. X equals to minus 3 by 4. For x equals to minus 3 by 4, what happens is that if I put here minus 3 by 4 minus 1, so minus 3 by 4 minus 1, I get minus 7 by 4 inside the absolute value. If I remove the absolute value, it would be 7 by 4. So on the left hand side we have 7 by 4. Now let's check the right hand side. So 5 into minus 3 by 4 is minus 15 by 4. So minus 15 by 4 minus plus 2. So plus 2. So this is minus, this is positive, and this is negative. So that doesn't hold true. So when they say we have to find the value, so the value is going to be x equals to minus 1 by 6. So you have to restate the answer, otherwise you will not get the final mark A1. So answer x equals to minus 1 by 6. This is the answer. Question number 7 is exponential function. This is exponential growth. If you remember, exponential growth is something that has this term, exponential growth. It has something like p or any alphabet, p equals to p naught e to the power k t. P naught is the initial value and k is the constant of growth and t is the time taken. So this is the exponential growth model. This is what it looks like. Exponential growth can also look like some other constant a plus b e to the power kt. It can look like this as well. So when we have exponential growth, the main thing is it has to be e to the power x. This is the main idea. It has to be e to the power x. So e to the power x, they're using the letter t for growth because time, usually for growth we use the letter t as in time. So this is an exponential growth sum. It's a very common sum in C3. So the first question they have given, a particular species of orchid is being studied. The population p at the time t years after the study started is assumed to be this expression. So given that there were 300 orchids when the study started, remember all the time they are going to give you the information when it started. So when it started or initially, it means t equal to 0. This information will always be given. So at the start, meaning when t equal to 0, the population was 300. So population p is 300. So this information is given. Let's plug this in. So what happens? 300 equals to 2800. We don't know what a is. E to the power, if we put 0 in this, so 0.2 into 0 is going to be 0, divided by 1 plus a. Again, if t is 0, it'll e to the power 0. So this would be 300 equals to 2800 a. E to the power 0 is 1, divided by 1 plus a. E to the power 0 is 1. So if we simplify this, so multiply 300 with 1 plus a, and you have 2800 a. So if you have 300 plus 300a equals to 2800a, so therefore 300 equals to 2800 minus 300a, it's going to be 2500a. So therefore a equals to, if I send this to the other side, 300 divided by 2500, and that is going to be 300 divided by 2500 0.12, and that's what they said. show that A equals to 0.12. So now that we know what the value of A is, we can write this population model as 2800 into 0.12 e to the power 0.2t divided by 1 plus 0.12 e to the power 0.12 t 0.2t. Okay, now use the equation with A equals to 0.12 to predict the number of years before the population of orchids reaches 1850. So when P equals to 1850, we have to know what is the value of T. So let's put the value 1850 equals to, now 2800 into 0.12 is going to be 2800 into 0.12 is going to be 336. So we can write here 336 e to the power 0.2t divided by 1 plus 0.12 e to the power 0.2t. So the calculation is going to be, we cross multiply, so 1850 1 plus 0.12 e to the power 0.2t equals to 336 e to the power 0.2t. So if you multiply, it would be 1850 plus 0.12 into 1850, 0.12 into 1850. This would be 222 e to the power 0.2t equals to 336 e to the power 0.2t. So let's bring all the e to the power t on one side and then solve it. So if you write 1850 equals to 336 e to the power 0.2t minus 222 e to the power 0.2t, so then it's going to be 1850 equals to 336 minus 222, that would be 114. So 114 e to the power 0.2t, so it would be e to the power 0.2t equals to 1850 divided by 114. I'm just writing this in the reverse order because this equal to this and this equal to this is the same thing. So this would be 1850 divided by 114. It would be 16.2281. 16.2281. So 16.2281, that would be the value. So therefore, now remember, this is an exponential function sums, and we need the formula for solving e to the power x equals to a, and that would be log. So ln a, ln means log base e. So for solving this, we need that logarithm formula. So 0.2t the power equals to ln 16.2281. Therefore t equals to ln 16.2281 divided by 0.2. So from here we can find the value of t. Therefore t equals to ln 16.2281 equals to this divided by 0.2. So that answer is 13.934. 13.934. Now did they tell us to write the answer in a certain way? Find the number of years. So number of years, we can write it 14 years, or we can write 13.9 years. You have to give the unit, otherwise you will not get the A1 mark. The next question, The next question is actually a simple algebra sum. You have to simplify the original question into this. It's a simple algebra question rather than anything to do with growth, exponential growth. So the original question was P equals to, let me copy it from here. So P equals to 336 e to the power 0.2t. 336 e to the power 0.2t divided by 1 plus 0.2 e to the power 0.2t. So this is what happens if you put the value of a equals to 0.12 in the original expression. This is what you get. Now our job is to simplify that expression into this. We have to simplify this expression into this. So what we have to do, we have to do some simple algebra. Now first thing that we have to do is we have to get rid of this e to the power 0.2t from upstairs, from the numerator. So what we do, upstairs and downstairs, let's divide by e to the power 0.2t. So we can write P equals to, so if you divide 336 e to the power 0.2t divided by e to the power 0.2t, then you'll have 1 plus 0.2t, 0.2, actually this is I think 0.12 because a equals to 0.12, yes, 0.12 e to the power 0.2t divided by e to the power 0.2t. So what we get, this thing and this thing cancels off. This would be 336 and this would be 1 divided by e to the power 0.2t plus 0.12 e to the power 0.2t divided by e to the power 0.2t. So what happens, this thing and these things will cancel off and we can write 336. If you bring this upstairs, it would be e to the power minus 0.2t and this would be only 0.12. So if we simplify this, we can write P equals to 336 divided by 0.12 plus e to the power minus 0.2t. So this algebra is a bit cumbersome and this is only 1 mark. So I don't think in the exam you should spend too much time on sums like this, which requires you to simplify something and only 1 mark. The best thing to do is just move on to the next one, question number D. This is a very common question. They're asking us why will it be that the population cannot exceed 2800. Now you remember that e to the power x looks like this. So y equals to e to the power x looks like this. So always above the x-axis, always above the x-axis. So it cannot be equal to 0 because it is always above the x-axis. So if you write for e to the power 0.2t, this is negative, so it doesn't really matter, equals to 0. If I put 0 here, p would be equals to 336 divided by 0.12 plus 0. This whole expression would be 0 then. So 336 divided by 0.12 is 2800. Since e to the power minus 0.2 is greater than 0, it cannot be equal to 0. So the population, if this is always greater than 0, so the population will always be less than 2800, because if you are dividing 336 with more than 0.12, because this will not be 0, this will be more, so it cannot exceed. So you don't have to do the arithmetic, just say since e to the power minus 0.2t is greater than 0, the population cannot exceed 2800. So that's it.